it's kind of, typical contamination steps failure. I was pointing those out. You can see the stages of what's happening, a little bit worse with the black to finally spun. Same two bearings. Again, you can see the contamination or where it ran out of oil. A little bit of overlay left, but here you can start seeing where everything's starting to get very hot. Once you get the bearing hot, it starts to contract into itself. So once it starts contracting, now it's worse, because now instead of having that clearance that I showed you at the beginning, the bearing is coming into itself. Now you're losing the ability for it to take oil in to create that hydrodynamic wedge that I was showing you on the first slide. Now you've lost that ability because the bearing is getting smaller and losing that, what you would set up as the oil clearance. It's taking it away because of frictional heat, bringing that back in. So this is typically an aluminum bimetal, kind of very similar situation. Aluminum bimetal is a steel with a aluminum alloy on top of it. It's a less expensive bearing to make and typically doesn't hold as much load capacity as a tri-metal would. In this case, again, this is some debris, but you can see the same thing happening here. You're losing the oil film, you're getting frictional heat. Aluminum is a higher melting point than the lead. So it's getting to a point where here it's starting to get black. You're getting some coking of the oil. The particles of mixed in with the aluminum in there are starting to melt out, and you're creating that black look. So, start-stop technology. I get it. A lot of us have driven cars with it. As a bearing guy, it freaks me out every time I get that. I can't find, where's that button at? Shut that button off, because I can't stand it anymore. So typically, every time an engine starts, it has to get, from a bearing standpoint to a crankshaft, you have to get the rotation of the crankshaft. You get rotation of the crankshaft, feeds in, builds the film pressure, and keeps the crankshaft and the bearing apart. In this case, we have startup. It starts up, gets on a hydrodynamic film. You take it like a skier. Once the skier gets out of the water, he's on plane and he just keeps cruising around. What happens when the boat slows down? Sinks. Start-stop technology. Boat takes off, he gets up on plane, gets to the first stoplight, goes off plane. Now you gotta pull himself out of the water again. There he goes, over and over and over and over. So every time you're in the red, you don't have hydrodynamic film. So you have the shaft, the crankshaft, and the bearing on each other. I can give you examples of when I did some studies on certain start-stop technology engines. The number 5 main bearing can run 3 to 3.5 seconds, be 600 RPMs before it ever gets any oil. Every time. So those are the problems that come in. So start-stop technologies. The government makes us do it, the manufacturers do it because they need to meet miles per gallon in their fleet of vehicles they're selling. There's CAFE standards. Coming into the aftermarket, we have to build an engine and sell it, and how do we fix this? So with that, there comes where we have coated bearings. All right, coated bearings is typically, and this is a XP, which is a performance tri-metal bearing, is a steel back, has a bronze substrate. It has based off in this case it'd be a copper tin lead overlay, and then there is a polymer over it. Bimetals, very similar, where you have a steel back, aluminum, as I mentioned earlier, and another polymer. So in this, I don't remember which slide I had. So in this case, so every time that engine stops, you get all plain. So what does the coating, what does the polymer do? The polymer, it creates two purposes. It's a dry film lubricant. So as that bearing, as the crankshaft cut touches it, it gives it a dry film lubricant to reduce the frictional heat. All right, so as you reduce the frictional heat, it doesn't cause the overlay to melt. Remember, lead melts 621 degrees Fahrenheit. So once that starts melting, your bearing starts to disintegrate itself. So the moly-based polymer is a dry film lubricant. The other advantage is in certain applications, there is a particulate that will be a wear coating. Your start-stop technology engines have a wear agent in them. So in this case, a lot of agents, they use like ceramic, they may use aluminum oxide, red oxide, and those are the wear particles. So when you get in contact, you get a wear particle to keep the bearing from wearing, because it's hitting on a harder particle. You have a moly base, which creates a dry film lubricant, and then a resin that holds it all together. So when you go back to this situation, where you're getting all these irregulars, the polymers in today's engine is what's going to save the engine. Now, being the OEs have to run lead free, lead is a great lubrication. I mean, here in the aftermarket, we get to use lead-based products, which is wonderful for the longevity of the engine. You know, the government says no lead. For a while, the only thing lead in the cars were the batteries. Now they're with lithium batteries, there's not even lead there. So a lot of the focus is on the polymers, wear agents to create the start-stop. Now on the same token, as a performance engine, if you get too much, you get a lot of crankshaft flex. I do a lot of presentations on the harmonics and crankshaft flex and wears, because you reduce by crank flex, you reduce the oil film thickness because the crank flexes and starts orbiting around. So you need some kind of a wear agent and a dry film lubricant to keep the bearing from seizing. That's where these advantages come in. Some kind of polymer coating with a wear agent on there. So before we go into questions, I also, there's some social medias we do. King Bearing is starting a tech series. We're doing a lot of tech videos about, you know, what happens and different things. I do a lot of presentations across that we're bringing to life, try to educate the consumers that are out there, engine builders, of what's going on. Because the way we used to build engines, had this conversation many times, what you used to do, you can't get by with anymore. You can take an engine now with these thinner oils, and oil moves faster. The thinner the oil is, the faster it moves. So the less margin you have in your build, you can, even with the crankshaft grindings, you can take gain grinding chatter, and you can get film pressure spikes. And if you get a 0.6 to 0.7 of a thousandths difference in grinding chatter, I can show you 4,000 PSI of film pressure spikes on thin oil. So the days of, you know, that was good enough, it worked 20 years ago, it's going to work now. You know, there's less margin as we have thinner oils. So that's why a lot of this is important, is what's the new technology. And just because this is what you used to do doesn't mean this is what you need to be doing now. At the end of the day, when you put your name on the valve cover and close the hood, it's important that you build as much margin in your product as you can, so you have customers forever, a good reputation. So with that, you know, check us out on Facebook, YouTube. We have some different tech videos. My email address is right here, so feel free. I'm the technical manager, so help answer a lot of questions that people have and how we can help them be better. So
brilliant. Okay, you got a question?
Dan, you talked about bimetal and trimetal bearings, and the OEs have all moved to bimetal, and the assumption is it's because it's an equally capable bearing. Are you saying that maybe lead and those kind of issues were part of the factor rather than performance when they made that decision?
So the OEs are moving to either a polymer or aluminum. polymer, again, for the start-stop technology. Aluminum, you can coat aluminum and create basically the same thing. It's a cost factor. Aluminum bearings, no matter what you do, because aluminum is softer, will never have the load capacity that a tri-metal has with the 3 layers, because aluminum just cannot support, and it can be, in some cases, it could be double, a tri-metal could be double the load capacity of a bimetal bearing. So in the performance world, I'm a huge tri-metal fan. If you're not doing any power adders or something like that, you can get aluminum. If you're marginal on what you do on your power adders, there's different surface enhanced aluminums that you can do that raise the load level on aluminum bearing, but it will still not achieve the same as a tri-metal bearing. Great question.
Any other questions out there? Anyone else like to ask a question before we conclude the segment? All right, I'll come to you. Stay put. I'll come to you.
So based on your video or your slides, should I always turn off the auto start on my car?
If you are a bearing person, yes.
If I'm a what?
A bearing person, yes. From a mileage standpoint, there's a reason it's on there. Okay, and the reason is on it is obviously it shuts off safe fuel mileage. The bearings in that application will have a polymer to help to combat that start-stop. Same token, again, based off the car, the oil feed in the block, et cetera, I can show you examples on my laptop of different OEs that have problems. Number 5 main bearing of load not having film pressure. So to answer your question is, if you want to save mileage, leave it on. If you want to save your engine, turn it off. So the other thing can happen on start-stop, a lot of people think about that. The other thing is the moment of inertia. So when you get with valve trains and so forth, the front of the engine is driving camshafts. Well, you have to get that to turn too. So in that reality, sometimes the crank is pulling up to get the moment of inertia to get the camshafts to spin through the belt, and you can get seizure on the upper. All right, performance engines, I can show you seizures all around because you get crank flex and so forth. So at the end of the day, it's contact. If you, from a bearing standpoint, I mean, you create less debris when the engine's not running. I'm a bearing guy, so that's where my mind's always at.
Okay, good question. Great answer.